All right, guys, so today we're going over the review sheet. Now, to be kind to y'all, we're going to do today and tomorrow, we're going to go through pretty much the entire thing so that y'all are ready for your test on Wednesday. All of your homework is going to be due at the end of the day Wednesday. So anything you don't have turned in, you need to get turned in. And if you're not sure of what you have missing, WinGauge is up to date. Everything that's been turned in has been handed or has been graded and put in there. So if there's not a grade for any part of Chapter 7, it's not going to be there. Yes, sir. Not so much today because we'll be going through it together. So if you are missing anything from Chapter 7, it's going to be not graded or not have a grade attached to it in WinGauge. If you turn anything in today, as of right now, it's not going to be up there, so the 2 assignments you turned in. So if you are missing any of the assignments or the papers, the worksheets, they are in Google Classroom. The paper assignments at the top, PDF of the book, right there, page number problems. You can look those up. Now for 1 through 9, these first 6, we're trying to determine whether it's direct, inverse, or neither. With direct variation, the general form of it is y is equal to a times x, where a is a constant amount that doesn't change. We did have another variation of the formula as y over x is equal to a. If it comes in either of these forms, it is considered direct variation. We also have inverse variation, which the main form of it is y is equal to a over x. Or its alternative form is y times x is equal to a. And if we boil it down to the generalist sense, if it's direct variation, x and y are on opposite sides, they're both in the numerator. For inverse, if x and y are on opposite sides, one's in the numerator, one's in the denominator, or vice versa. If they're on the same side and being divided, and it's equal to a number, it is direct. If they're on the same side and being multiplied, it is inverse. So if we look at problems 1 through 6, we're just going through and determining is it direct or inverse variation. And if we look at number 1, it would be direct. Even though the 8 is attached to y, it really doesn't make a difference because we could divide it from both sides, it's still the same. X times a is equal to y, or y times a is equal to x. Those are the exact same thing. Number 2 would be inverse, because this is our x times y is equal to a. And number 3 would be neither. What's the big giveaway? So multiplying, we have addition. If we have addition or subtraction, it's going to be neither, because direct and inverse variation are only using multiplication or division, one or the other. Now number 4 would be inverse, because y is equal to a over x. If x and y are on opposite sides, there is no addition or subtraction. One's in the numerator, one's in the denominator, it is inverse. If they're on opposite sides and both are in the numerator, it is direct. Number 5 is almost inverse. Because again, we're really matching them up to one of these two here. X and y are on the same side, they're being multiplied, it's inverse. If they're all on the same side and being divided, it is direct. And the last one is neither, because of the plus. Because of the plus, it's going to be neither. Questions on these here? Hopefully out of any of 1 through 6 on the test, you'll get at least the ones that are neither, because it's plus or minus, there's addition or subtraction. Now let's look 7, 8, and 9. Again, these we're still working with direct, inverse, or neither, but this time we're looking at direct as y over x is equal to a, or inverse is x times y is equal to a, because the a is a constant amount, it doesn't change. So if I divide the x and y's by each other and get the same amount every single time, it is direct. If I multiply them together, x times y, and get the same amount, then it is inverse, because the amount of change between each one will be the same. So for 17, if we do 16 divided by 4, we get 4. The next one, 11 divided by 5 is 2.2. Are those the same amount? No. So number 7 is not direct. Now we can look at inverse. So we can say 4 times 16 is 64. We can do 5 times 11, which is, so this is neither. Since multiplying them together did not give us the same amount every single time, and dividing them did not give us the same amount every single time, it is neither. Yes. Now for 18, we can start off with just dividing. We can start off with checking to see if it's direct first. 14 over 7 is 2. 22 over 11 is 28 over 14. 34 over 17. 42 over 21. And 50 over 25. So this is direct. Now on the test, I would make sure to check every single one, because just because the first 5 work doesn't mean the 6th one will too. Any questions on 7 or 8? Now if we look at 9, 9's a little bit different, because I should have just left the last one off. Because if we divide, 29 divided by 2 is 14.5. We can plug that in a calculator and it would do it for us. The next one, 14.5 divided by 4. Well, is this going to give us 14.5? No, I don't even need to calculate it. We could plug it in a calculator and get 3.625 as the answer. And no, I didn't do that in my head. I more or less cheated off the table, because that's half. So half of that is that, so twice that. But this is not direct. So the other choice is inverse. And if we do 2 times 29 is 58. 4 times 14.5 is 8 times 7.25. 16 times 3.625. 24 times 2.416 repeated is 58. And unfortunately, the decimal after that got very funky for the next one. It still works out to be 58 approximately. So this is inverse. Really, I just need to remove this from it and it would work out fine, but it is inverse. Because it almost, I think the last one, if you plug that whole thing in, you get 57.999, something really, really close. It's just I couldn't put the decimal out far enough to get you a nice answer without having to do it by hand. So that's what we get. The ones on the test are going to be exactly every single time or not, one or the other, and it's not going to be approximating on any level. Questions on 1 through 9. 10, number 10. Simplify each expression if possible. So when we simplify each expression, we're factoring the numerator and denominator as far as possible, and then simplifying like expressions on top and bottom. Now 2x squared is a monomial, it's a single term. We can't do anything to it. 2x squared stays the same. Now the denominator, 3x squared minus 4x. The first thing you should always look for is greatest common factor. That's the first place we should always start. And there's a greatest common factor of x. We can factor out of both terms. If we factor an x out of 3x squared, we get 3x. minus 4. Because we take an x away from 4x, we're left with 4. Now this is factored as far as it goes. One reason, because we've factored out every greatest common factor. Inside the parentheses, we have 3x minus 4. The degree is 1. X only has a 1 in the exponent, so that's as simplified as it gets. The only way we would know for sure that it could factor is if we had an x squared, x cubed, we have x to a power greater than 1, then there's a possibility that it could factor. But here, it's as simplified as it gets. Now, is there anything in common on top and bottom? We have an x on top and bottom, yes? So they simplify out, or we subtract the exponents. Because when we have like bases on top and bottom, we subtract the exponents. So 2 minus 1 is 1. Is it bigger on top or bottom? Top, so it stays on top. So we have 2x on top. On bottom we have 3x minus 4. And that's as simplified as it gets. Now we're not going to go into restrictions. There are no spot, especially on the test, that I'm going to specifically ask for restrictions. The only spot where it is helpful is when we're solving equations, solving rational equations that have restrictions. Then it's good to list them out just to make sure that we don't leave a restriction as one of the answers. But this is it. If we were looking for the restrictions, x cannot be 0, because that there cannot be 0. And what would make 3x minus 4 be 0 is 4/3. So if we had 0 or 4/3, we would have a denominator of 0, and it would not work. Questions on this here? Now, we're not going to look at number 11, not because of anything mainly specifically. The only real reason is there's not something that complicated going to show up on the test. And the only real complicated part of it is that, one, we're factoring the denominator by grouping, and the numerator is a different or perfect fourth powers. It would factor, but we're not going to worry about this here. However, we will look at number 12. Incidentally, difference of perfect cubes is not going to show up on the test. So I'll go on and give you that there. But we do need to factor the numerator. X squared minus 7x plus 12. If we look at the 12, before we do two sets of parentheses, really, we look for greatest common factor. A lot of times I end up skipping over it mainly because I look at the equation and see the number in front of x squared. Here, the number in front of x squared is 1. So the likelihood that we have a greatest common factor is almost nil, almost 0. And if we also look at the three terms, is there a variable in common? No. So most likely there's not a greatest common factor. So we can move on to the two sets of parentheses. Since the third term's positive, our signs are the same and match the sign of the middle term. So we have negative and negative. Factors of x squared are x and x. Now, out of all the factors of 12, we have 1 and 12, 2 and 6, 3 and 4. 3 and 4. We want 3 and 4 because we want the middle term to be 7. 3 and 4 would give us 7. Also, if it is 3 and 4, we do have something in common on top and bottom, which would cause the x minus 3 and x minus 3 to go away, leaving us with x minus 4 over x squared plus 3x plus 9. And that would be the final answer. Now, we don't even need to check to see if x squared plus 3x plus 9 factors, mainly because, again, the difference or sum of perfect cubes, the quadratic that comes out of it, so here x squared plus 3x plus 9 will never factor. Its solutions will always be complex. They will always contain I no matter what they are. So that means two things. One, x squared plus 3x plus 9 will never factor. We just know it because it came from the sum or difference of perfect cubes. Also, it means that x squared plus 3x plus 9 will not cross the x-axis. It can't be 0. So we will never have restrictions from it either. If we were going to look for restrictions, the linear part of it, the x minus 3, would be the only place we could get restrictions from it. Which means x cannot be 3. And it's the only plot that would most likely cancel out unless x squared plus 3x plus 9 did show up in the numerator. Any questions on any of this so far? I know I'm going at a decent pace. Let's look at 13. Now, numerator and denominator, there is not a greatest common factor. So, let's look at the next part. X squared minus 4x minus 12 and x squared minus 4. There is no greatest common factor in the numerator or denominator. X squared is by itself, and there's no variables through all three. Now, which one we factor first doesn't really matter. I would always pick the one that I can see the factors of first or easier. In between the two, the denominator, I see or think it's a little bit easier to factor because we have x squared minus 4. X squared is a perfect square. 4 is a perfect square. Since we only have two terms and they're being subtracted, it's a difference of perfect squares. X would be x and x. 4 is 2 and 2, and we have plus and minus. And I always start out with which one is, I think, is easier to factor, because if there's going to be something in common on top and bottom, one of the factors in the numerators has to be either x plus 2 or x minus 2. It has to be one of those two for us to have something in common. Now, if we look at the numerator, the 12 is negative, so our signs are opposite, positive and negative. The only factors of x squared that we have are x and x. Now, the factors of 12 are 1 and 12, 2 and 6, or 3 and 4. We would want 2 and 6. Which one's going to be positive? And 6 would be negative. To get us a middle term that's negative, we need the bigger one to be negative. And we want 2 and 6 because if we need something in common on top and bottom, we need one of them to be plus 2 or minus 2. So we do have x plus 2 in common, so those would cancel out, leaving us with x minus 6 over x minus 2, and that's as simplified as it gets. Questions on this here? And we wouldn't look at restrictions, but if we did, x cannot be 2 or negative 2. We couldn't have positive or negative 2. Any questions on this so far? The next thing we're looking at is multiplication. Now, multiplication of monomial rational expressions, when we say monomial, it's just a single term on top and bottom. When we look at one like 14, the first thing I would do is just multiply straight across. Just multiply them together, then simplify from there. Now, if we look at the numerator, well, 4 is the only number on top. If we had two numbers on top, we just multiply them together. So we get 4. Then there's only one x. If there was multiple, we would multiply them together by adding their exponents. When the bases are the same, we add the exponents. Thank you. But we do have y's. We have y to the third times y, which would be y to the fourth. It's not written in, but that exponent's 1. 3 plus 1 is 4. Now the denominator, 8's the only number, so we just have 8 out front. Now we do have x squared times x, which is x to the third, and then y. Now at this point, we do need to simplify like terms on top and bottom. So 4 over 8 reduces to 1 over 2. 4/8 is the same as 1/2. Now, personally, I will write the 2 on bottom. I will leave any 1s till the end. Because if it works out that everything in the numerator is simplified, we'd rewrite it back in as 1, and that would be it. If anything else stays in the numerator, it can take its place. Now the next one is x over x to the third. Whenever we divide like bases, we subtract the exponents. So 3 minus 1 is 2. Now is it bigger on top or bottom? Bottom, so it stays on bottom. Essentially what we're doing is removing 1 from top and bottom. Because we only had 1 on top, in common with 1 on bottom, we would remove them. So the 1 on top's gone. And since I took 1 away from the 3 on bottom, it is now 2. That's really all we're doing. Now the last one, y to the fourth over y. We can do 4 minus 1, which is, and since it's bigger on top, it stays on. Or another way to think of it is that we're removing 1 from the top and bottom. Because there's 1 in common on top and bottom, we remove it. The ones in the denominator are now gone. And since we took 1 away from the numerator, it goes from 4 to 3. And that's it. Because we have 4 y's on top, we've got 1 on bottom. So any that are in common would go away. So it'd take 1 away from top and bottom, leaving us with 3 on top. Any other questions on 14? 15. Since we have polynomials, more than one term on top and bottom of each rational expression, we need to factor them first. So x squared minus 4x. They have a greatest common factor of x. So we can factor it out. If we factor an x from x squared, we have x minus 4. X times x minus 4. And that's all we need to do because x minus 4 is as simplified as it gets. We factored everything out. The denominator, x minus 1, is as simplified as it gets. There's no greatest common factor between x and 1. Well, other than 1. Doesn't really help us. X is to the first power, so that is as simplified as it gets. 2x is a monomial term, a single term. It's actually as simplified as it gets. We don't have to do anything with it. The only other one we have to do something to is the x squared plus 3x minus 4. Now looking at all three terms, there's not a greatest common factor to pull out, so we can do our 2 sets of parentheses with 3 spaces. Since the 4 is negative, our signs are opposite. One is positive, one is negative. Factors of x squared are x and x. Now the factors of 4 are 1 and 4 or 2 and 2. 1 and 4, we want the 4 is positive, 1 is negative. Partially because we need the 3x to be positive, so we want the bigger term out of the distributive property to be positive. And also, for us to have something in common on top and bottom, we need one of them to be x minus 1. And now that we have this, we can essentially combine them. We're multiplying the numerator and denominator, which, since they're factors, just putting them next to each other. And what do we have in common? Well, x minus 1 and x minus 1. We also have the x and x. And since there's only one x by themselves out front on both, they just cancel each other out. Now what that leaves us with is x minus 4 times x plus 4 over 2. We don't have to multiply that back out on top. We can leave it as this here. Any other questions on this here? Any other questions on 1 through 15? Are you ready for the next one? The next two, yep, we'll go on and do these here. Now with 16, again, the first thing I would do is factor. And the place I would start is whichever one of these 4 spots, the 2 numerators and 2 denominators, that looks like it'd be easiest to factor first. I'd say the 2x squared plus 4x, because they have a greatest common factor of 2x. And if I take 2x out of 2x squared, I have x plus 2. Because if I factor a 2 out of 4, I'm left with 2, and the x factors out completely. Now, the next one that we pick is really up to your personal preference between the other three because they're all about the same. I'm going to pick x squared plus 3x minus 4, mainly because that's just one to pick. Also, we literally just did it not 2 minutes ago. Since the 4 is negative, our signs are opposite. Factors of x squared are x and x, 4 and 1. Now at this point here, we can pick either one of these two. So we can do x squared plus 4x plus 4. No greatest common factor. And since the third term's positive, the signs are the same and match the sign of the middle term. Plus and plus. X squared would be x and x, and 4 would be 2 and 2. It'd be very tempting to do 1 and 4 because we do have an x plus 4 on top. But to get a middle term of 4, we need it to be 2 and 2. If it had been plus 5x in the middle, then it would be 1 and 4. However, with 2 and 2 does give us a common factor of x plus 2 on top and bottom that will eventually cancel. Now the last one, x squared minus 4x plus 3. Since we have the plus 3, our signs would be the same, and it would be negative and negative. It'd match the sign of the middle term. Factors of x squared are x and x, and the only factors of 3 are 1 and 3. And I probably threw you all for a loop there for a second when I wrote plus. But it should be minus and minus. And we multiply them together, we can really connect them because multiplying factored is just really putting them all together. And we do have an x minus 1 and x minus 1 on top and bottom. We also have an x plus 2 and, which leaves us with 2x times x plus 4 over plus 2 times and that's it. And again, we don't have to list the restrictions. I did that on the review sheet, but you won't have to do that on the test. Any other questions on number 16? All right. Let's look at number 17. Now with any of these here, division or multiplication, if one of the expressions does not have a denominator, it's understood to be 1. We don't have to write a denominator of 1 back in, but we do have to do that for numerators. And again, at this point here, we're going to factor, and I feel like x squared minus 16 is probably going to be the easiest one to factor out of the remaining 3 because it is a difference of perfect squares. Because x squared is x and x, we have plus and minus, and 16 would be 4 and 4. It's our difference of perfect squares. Now from here, we can move to the numerator, x squared minus x minus 12. Since the 12 is negative, our signs are opposite, positive and negative. Factors of x squared are x and x. Now the factors of 12 are 1 and 12, 2 and 6, 3 and 4. We would want 3 and 4. Since the middle term is negative, we want the 3 to be positive and the 4 to be negative. Now we haven't been checking any of these here, but it is sometimes good to check to make sure we do get the correct ones. Now the last one, x squared plus 2x minus 8. Since the 8 is negative, our signs are opposite, positive and negative. The factors of x squared are x and x. Factors of 8 are 1 and 8 or 2 and 4. 2 and 4, we would want the 4 to be positive and the 2 to be negative. To get a middle term, that is positive 2x. Any questions on how we factored this here? With multiplying, we can essentially connect them together. We don't have to rewrite this out. But what we have in common on top is x minus 4 and x minus 4. We also have x plus 4 and x plus 4. Do we have anything left in the denominator besides 1? No. So we don't have to rewrite it back out. We don't have to write over 1. We do have to write it out if it's in the numerator. So all we have left is 3 times x minus 2. That would be the final answer. We could put it all over 1. That would be the exact same thing. Either way would work. If it was the other way, if it was supposed to be in the denominator and you didn't put it there, that would be the wrong answer. If it's supposed to be 1 over x plus 3 times x minus 2, that is completely different than just x plus 3 times x minus 2. Any questions on these two here? We ready for the next two? Now the next two here are essentially the exact same as what we've been doing. Whenever we divide two rational expressions, the first thing I would say to do is keep the first one the same, change it from division to multiplication, and flip the second. Before you do anything else, change it to multiplication and flip the second. This is where I would start. Keep, change, flip. Now, since the numerator and denominator, the top and bottom of both fractions are monomial, they're a single term, we don't have addition and subtraction, we're going to go on and multiply them together. So the first thing we can do is 32 times 8 is 256. The next thing we can do is y to the third time, or not y, x to the third times x to the fourth. Since the bases are the same, we add the exponent. So 3 plus 4 is 7, and then we have a single y. The denominator is y to the 8 times y to the 7th would be y to the 15th. Any questions on this here before we start simplifying? Well, we only have one thing in common on top and bottom, and that is the y's. So we'll still have 256. We'll still have x to the 7th. But we only have one y on top, 15 on bottom. So 1 will cancel out on top and bottom. The numerator would simplify out completely, and the denominator would turn into y to the 14th. Or we're saying 15 minus 1 is 14. Since it's bigger on bottom, it stays on bottom. And that's it. Any questions on this here? We ready for number 19? Now again, just like with number 18, the first thing I would do is change it from division to multiplication and flip the second. So we'll still have x squared minus 3x minus 40 and x squared plus 8x minus 20. Change it from division to multiplication and flip it. So now the numerator is x squared plus 12x plus 20 over x squared plus 13x plus 40. So next thing we need to do is just factor each of these here and then simplify out. So we can just start off with x squared minus 3x minus 40. Since the 40 is negative, our signs would be opposite. One's going to be positive, one's going to be negative. The factors of x squared are x and x. Now we can look at the factors of 40, which are 1 and 40, 2 and 20, 4 and 10, 8 and 5, or 5 and 8. And we want positive 5 and negative 8 to get a middle term of negative 3. Now, we can move just straight to the denominator. X squared plus 8x minus 20. Since the 20 is negative, our signs are opposite. Positive and negative. Factors of x squared are going to be x and x. Now, factors of 20 are 1 and 20, 2 and 10, 4 and 5. And we'll want 10 and 2 to give us a negative 8, or positive 8, sorry. Positive 8. Questions on this here? Now the numerator of our next rational expression, x squared plus 12x plus 20. Since the 20 is positive, the signs are the same and match the sign of the middle term, so we'd have plus and plus. Our factors of x squared are x and x, and the factors of 20 are, well, all of them are 1 and 20, 2 and 10, 4 and 5. We would want 2 and 10. Because 2 and 10 is going to be the only way we have something in common on top and bottom. Since we do have x plus 10 on bottom already, x plus 10 would be nice to have on top. Now the last one, x squared plus 13x plus 40. Plus and plus. Since 40 is positive, the signs are the same and match the sign of the middle term. Plus and plus. Factors of x squared are x and x. Well, again, the factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. We would want 5 and 8 because 5 plus 8 would give us 13. Any questions on this here? And again, if you're looking for these here, it's sometimes good to check them to make sure we do have the correct factors. And at this point here, we multiply them together, then cancel out what's in common. Now, canceling out what's in common, we would have the x plus 10 and plus 10. We'd also have the x plus 5 and x plus 5, which would leave us with x minus 8 and x plus 2 on top, and x minus 2 and x plus 8 on bottom. And that's as simplified as it gets. Now, if you remember back to some of the lessons, we did have a few problems where we could factor out a -1 and get something in common, but that only worked if the signs for the two were both opposite. Since like x plus 2, x minus 2, since they're not completely opposites of each other, we can't do that. This is as simplified as it gets. Any questions on these here? Now I want to look at 20 here. This is the last one we'll look at today. Whenever we use addition or subtraction, the denominators have to be the same. Here, they're already the same as 2x minus 1. Now, whenever we subtract, we do need to be careful with our signs, but here, it's not too bad. It's just going to be 4x squared minus 1. We're subtracting the second term from it. Since it's just one term, it's not too bad. Now, we can't combine the 4x squared and 1, so that is our expression. However, 4x squared minus 1, 4x squared is a perfect square. It's 2x and 2x. 1 is a perfect square. It's 1 and 1. So this is a difference of perfect squares. It would be 2x plus 1 times 2x minus 1. And the reason we bring that up is because if we factor it, we do have like terms on top and bottom of 2x minus 1, which will cancel out, leaving us with 2x plus 1. So again, whenever the numerator has an exponent of 2 or greater, check to see if it factors. Here it did, so it left us with 2x plus 1. We will pick this up tomorrow, and your test is Wednesday.